using quadratic formula. I'm not going to go through the proof, but the quadratic formula basically states that if we have ax squared plus bx plus c equal to 0, then, and only then, when it's in that form, x is going to equal negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac, with the entire thing over 2 times a. For example, suppose we have x squared plus 5x plus 6 equals 0. In this case, because there's not a number in front of the x squared, that is understood to be 1. So a is equal to 1, b is equal to 5, c is equal to 6. They happen to all be positive. So if x is the negative of b plus or minus the square root of b squared minus 4ac all over 2a, and that's going to give us the negative of 5 plus or minus the square root 5 squared minus 4 times 1 times 6. This is a and c, with the entire thing over 2 times a. Make sure that you get this fraction line extended all the way over so that it's under the minus 5, because it makes a big difference as to whether or not the 5 is in the fraction or beside the fraction. Now, the first time you ever go through this, there are 4 places you want to look at. This could be minus a negative, in which case you want to change it to a plus. And then this has to be squared out, this has to be multiplied out, and this has to be multiplied out. So we have negative 5, nothing to change there, plus or minus the square root of 5 squared is 25. If both of these numbers are positive, then this will stay a negative. If one of these is negative, that becomes a positive. And if both of these are negative, so that we've got 3 negatives, then it'll be a negative. So in this case, it's a negative. There's only one. So minus 24, 4 times 1 times 6, all over 2. So we've got negative 5 plus or minus the square root of 1, 25 minus 24, over 2. Sometimes people forget that the square root of 1 is a 1. So we've got minus 5 plus or minus 1 over 2. And then because these are like terms, because that came out of the radical, then I need to go ahead and separate these out into 2 separate problems. One is negative 5 plus 1 over 2, and the other will be negative 5 minus 1 over 2. This is going to be negative 4 over 2, which is negative 2. This will be negative 6 over 2, which is negative 3. How about I don't know, let's go with 2x squared plus x minus 3 equals 0. A is 2, B is 1, C is negative 3, because this is a 1x. It's never going to be the x. None of these, the A, B, and C, will ever have an x in them. You cannot have what you're solving for on both sides of the equation. You can't say x is, well, x. So your answer for x is never going to contain an x. So we've got negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 3 over 2 times A is 2. So negative 1 plus or minus the square root of 1. 1 squared is 1. This is going to be a plus, since we've got two negatives multiplied together. 4 times 2 is 8, times 3 is 24, over 4. Negative 1 plus or minus the square root of 25, over 4 would be negative 1 plus or minus the square root of 25 is 5, over 4. And since it came out of the radical, we need to split it up. See, this actually is two different problems, one with a plus and one with a minus, but since until we get to here, every step would be exactly the same, it doesn't make any sense to do all exactly the same stuff, just to have a plus in one stage and then a minus in the other. So it just combines two problems into one. So it's a multitasking formula. So we've got negative 1 plus 5 over 4, negative 1 minus 5 over 4. This one's going to give us 4 over 4 is 1. And this one is negative 6 over 4, which will reduce to a negative 3/2. And that's it.